By the way, there are no logarithms on any assessment this semester. Everything stops with 3.2. So those of you that are doing the review work and looking at that stuff, there are no logarithms there. We're just working now on getting ready for next semester. So, if my notes are right, we left off at number 11. So I'm going to finish off this first column here. I'm on page 26 of my notes. And if you recall, I think number 13 is probably the easiest one to start with because this is 6 to the first. There's an understood 1 there. And our property of logarithms, one of the only ones we know so far, says that when these two numbers match, the answer is the exponent. So the log base 6 of 6 to the first is just 1. So the key with these other two problems is to make this number match the base. So if I'm looking at 14, I need to get rid of the square root. Does anyone remember what power a square root is? I want to change the square root of 7 into 7 to some power.
2.
Not 2. You're close. 7 squared would be 49. I don't want 49. I want the square root. It's 1/2. Remember, fractional exponents, and we can even write this, I don't know where to write. We can even write this down, well, for now. X to the 1/2 means the square root of x. So fractional exponents mean radicals, and radicals mean fractional exponents. So when we have the square root of 7, we think of that as 7 to the 1/2, because that's what a square root means. Now, once these two numbers are the same, I mean identically the same, then the answer is just the exponent. So the answer to number 14 is 1/2. Because the square root of 7 is 7 to the 1/2. Now, this one is a little tricky because there's no base. So you have to remember what we talked about last time. If there's an LOG, there is a base there. Anybody remember what that base is?
10.
Yep, there's a 10 there. So I would go ahead and just write that 10 in. Every time you see an LOG that doesn't already have a base, like these already had bases, anytime you see an LOG without a base, stick a 10 in there. Now, we need this guy to be 10 to a power. So 100 is 10 to what power? 10 to the 10th?
No, it's 10 to the what, 2?
Yeah, 10 to the 2nd. Because 100 is 10 times 10, right? So 100 is 10 squared. So I have to have these two numbers matching. So I change the 100 into 10 squared because I had to have a 10 to match this. So the answer to the problem is just 2. Remember, once you get these two numbers matching, the answer is the exponent. Always, always, always. All right, let's look at 15, 16, and 17. Now, don't be confused by the ln. Does anybody remember what ln stands for? I told you the other day. Did I write it down?
Log E.
Exactly. So I'm going to rewrite this as log base E. Now that's this. So that has been written like this. So now I have e to the 10th. I have the log base E of e to the 10th. See how these two match? What's the answer to the question? Yeah, that's it. That's it. Now, the next one looks harder, but it really isn't. ln is log base E. Now, what power is a cube root? Now remember, a minute ago, we said a square root was the 1/2 power. So what's a cube root going to be? X to what power? Exactly. So cube root of E is e to the 1/3. Remember, radicals are fractional exponents. So we have the log base E of e to the 1/3. These match, so the answer is just 1/3. Now 17 is kind of the same but a little bit different. There's no radical, okay? So if there's no radical, then you're not going to have a fraction. The only way you're going to have a fractional exponent is if you have a radical, okay? So don't think radical here. It's a log base E. Now, I have to write 1/e as e to a power. Now stop and think, how do we get 1/? With exponents, how do we get 1/? Something? What kind of exponents give me 1/? Yes, very good. Remember, kids, if you have x to the -2nd, isn't that 1/x squared? Isn't that how we write that? So if we have 1/e, that's going to be e to the -1st, because e to the -1st means 1/. So the answer to this problem, 17, is just -1. Remember, when these match, the answer is your exponent. Now I'm going to skip around a little bit here because I want to do all of these problems that are the same. So I'm going to do 18 and 19. These look a little different than the ones we've been doing, but these all look alike. 22, 23, 24. Now, and the good news is, none of these require any work. You are going to be able to look at these problems and give the answer. All right, so I skipped around. These are all exactly the same kind of problem. 18, 19, 22, 23, 24, 25, and 27. They're all exactly the same. We have a property we wrote down that said when these two numbers matched, the answer was just the exponent. So P was the answer. We've been using that on these problems. Well, there's also a property that says when these two numbers match. So when this and this are the same, then the answer is just right here, that guy. So in 19, the answer would just be 2. When these match, that's the answer. Now some of you are saying, well, Mrs. Ford, 22 looks way different. No, not if you think about it. What does LN stand for?
Hey, Mrs. Ford.
Yes.
On number 19, how did you get 2?
Because these two numbers match, and when that happens, the answer is always that.
Okay, thank you. Thanks.
So now I'm looking at 22, which is exactly the same thing, but ln, remember, is log base e. So now these two numbers match, so the answer is 4. ln, rewrite it, log base e. Then you see the match, so the answer is that number right there. What's the answer to 23?
11.
11. Yep, perfect. What's the answer to 24?
7.
Yep. Now, 25 is another tricky one because you don't see a base. But remember, log is a base 10, so the answer is 7. What's the answer to 27? Anybody know?
6.
Yeah, indeed, because this is log base e. ln is log base e. So that's another one of our properties that we're going to kind of remember. When these two numbers match, the answer is the other one. So when the base of the exponent and the base of the logarithm match, the answer is the other number. Every time. So those are actually kind of easy once you get the pattern figured out. When this number and this number match, the answer is the exponent. So now we're going to finish up this page and then we'll be done for the day. So what's left here? Let's see. Well, I could do 20, right? And 21. All right, so I'll start with those two. Okay, so number 20. Now, this one's a little bit confusing because there's a number out in front of it. So what I'd like you to do is just put that number on hold. So let's just forget about him for a minute, and let's look at this. Now, remember, your goal is to turn that 9 into a 3 because you want these to match. So what do we know about 9? 9 is 3 to what power?
Squared.
Yep. So since 9 is 3 squared, now these two match, and the answer to that is just 2. So the answer to this part of the problem is 2. But don't forget, in the beginning, the problem had 2 times that. So what is the final answer to that problem? The answer to this part was 2. But now we got to take 2 times that. So the answer is actually 4. 2 times 2. So we did the logarithm part separately. Got 2 as our answer. So 2 times 2 is 4. Now let's do exactly the same thing for this one. Forget this 3. Just cover it up. Now you need these two numbers to match. So the log base 2, 8 is 2 to what power?
3.
Yep. So the answer to this part of the problem, those cancel. So the answer to this part of the problem is 3. But now I got to take the answer to that part of the problem and multiply it by 3. So the actual answer to the problem is 9. Would you try 26? It is exactly the same kind of problem. Can you see if you can figure out the answer to number 26? Cover that 4 up. What's the answer to this? What's the log base 2 of 2 to the first? What is the answer to this part in the circle? Remember, if these match, the answer is the exponent. So what's my exponent? 1. 2 to the first. So the answer to this part is 1. But I have to multiply that by 4, so the answer to the whole problem is 4. We seem to be getting hung up when we have something like this. Remember, there's a 1 exponent on that. So the log base 6 of 6 is 1. The log base 7 of 7 is 1. There's always an understood 1 exponent on everything. But if these numbers match, then the answer is going to be 1. And then the last one, the log base 8 of 1. This should be written on your paper somewhere. Does anybody know what the answer to this is? We talked about it last time. Not today yet.
0.
Yes. Yes. Guys, the log base anything of 1 is going to be 0. So if this were a 9, it would still be 0. If this were an E, it would still be 0. The log base anything of 1 is always 0. Okay? You know, I said we were going to stop, but I didn't realize we said quite a bit of time. Let's do the calculator part. So we'll just do number 2, and then I promise we'll stop. Let's grab our calculators, and let's type in part 2, which is on the back of page 26. It says evaluate with a calculator. So this is easy. We're just going to type it in. Obviously, you got to have a calculator, though.
Wait, is that part 3 or for part 2?
We're ready for part 2. Number 2, evaluate with calculator, round to the 10,000th. Okay? So here we go. On your calculator, you have 2 log buttons. They're right here. You got a log and an LM button, right? So the A says log 8.61. So just hit log and then 8.61 and enter. And for problem A, did you get 0.9350? Remember, 10,000th is 4 decimal places. Anybody have a question about that? Did everybody get that on your calculator?
I'm still trying to find it. But...
Find your calculator. Okay, so the next one says ln 12. So now we're going to use our ln button. So just press the ln button and then 12. And I got 2.4849. Again, rounding off to 4 decimal places because that's what the directions said. So if it's an LOG, I use my LOG button. If it's an LN, I use my LN button. Really easy. All right, what about C? Yeah, go ahead.
What'd you put after the log?
The number they gave me.
Okay.
So I just typed exactly what's written on the sheet. So has anybody done C, ln -9? Don't freak out. What happened?
Error.
Yeah. Kids, you cannot take the logarithm of a negative number. So either whether it's log or whether it's ln, if this number is negative, you can't do it. You cannot do it. It's imaginary. Okay? So that's out. All right, next, D, log. 15.47. 1.1895. 1.1895. All right, why don't you try the last four? Try E, F, G, and H. And we'll look at your answers and everybody's answers and compare, and then we will be done.
This is 4.
Yes.
Could you hold the paper because I still can't find it? And I have all my pages, I just don't.
Okay, it's the back of the page we were just doing. So we did these problems at the beginning and I just turned it over. It's on the back. It says evaluate with calculator. Number 2. Did you print it from Schoology? It wouldn't be on the back then. I forgot I didn't give you this packet. You had to print it. But it's the back.
I have separate pages, but I don't need that page printed on.
Okay.
I'll get it though.
All right. Anybody get an answer to E?
I got a negative.
It's fine. You can get a negative answer. There's nothing wrong with that. That will happen a lot. What did you get?
Negative 3.13.
Okay, well, let's be careful. Make sure we're rounding like we're supposed to.
3.14 then.
So it would be negative 3.1355. We want 4 decimal places. So we have 0.13549. So we'll round that off to negative 3.1355. It is perfectly okay. When the calculator says a negative, that is fine. Now, what happened with F? The calculator didn't say negative. You put a negative in, and what happened?
No answer.
No answer. You're not going to get an answer to problem F because you cannot input a negative number. It just won't work. And G, same thing. No answer to G. Anybody get H? Log of 1977?
I got 3.2960.
2960. How about the rest of you? What do you think about that? I agree with her 100%. 3.2960. So real easy inputting this stuff on our calculator. When we get to the word problems and we start typing these in, It's going to be easy. You just type in whatever it says on the paper. Whatever your problem says, you type it in, and whatever comes out, even if it's negative, is okay. That's the answer. All right? Now, I'm going to hang on and do any, those of you that are going to take the exponent quiz next time, I'm going to hang on in case anybody has a question about an exponent problem. Again, none of this is on any quiz or quest. This will be after Christmas that we do all this. Okay, so you guys are free to go. Take care of yourselves. Reach out if you need anything. If you want to stay on and do an exponent problem, then I will do that. Stand right here to do exponent problems.
It's Gabe's birthday today, so
I believe it is.
just like try to text him. He was really good friends with John.
I know.
Thank you, Ms. Ford.
We'll see you. Bye-bye.
So is the test gonna be tomorrow?
Well, it's an exponent quiz, and it's Wednesday, and it's optional. So kids who don't feel like they can focus enough to take it, everybody's going to take it, but you don't have to submit it for grading. And it's Wednesday.
All right. Thank you.
Thank you, Miss Ford.
You're welcome. Does anyone want an exponent problem?
Yeah, I'll send this over again.
Okay, Miriam, are you there or are you gone? Oh, she's gone. All right, so what exponent problem do you have, Farrell?
Yes, sir. Find the notes.
While you're looking, I'm going to put my attendance in real quick. Okay, so we were missing. All right, so no Antoine. And no David. Oh my gosh, Farrell Jonathan's still in my attendance. Huh. All right, what have you got for me?
First, I get it, Miss Ford. I know it's hard. Probably number 4.
Can you read me the
Where's,
problem?
like 1/2 times 1/5 and then to the power -1.
Okay, so what we have to remember on these is PEMDAS. So we have to do the exponent first. So I know that a negative exponent flips my fraction, or flips this, whatever this is, it flips it over.
Right.
So now I have 1/2 times 5/1. Since that's a 1, I don't even really need to worry about it because anything to the first power is just itself. So that flips over, and now I just multiply straight across, so I get 5 times 1, 2 times 1, 5/2.
And then can we do number 5, J?
Okay, read that to me.
It's 9/100 to the negative power of 3/2.
All right. So just like this one, we have a negative exponent. So we have to flip our fraction. Now the fraction that flips is this one. Don't be messing with your exponent. You flip this over, so it's 100 over 9. And now it's to the positive 3/2 power. The flip is the negative part. Fractional exponents mean radicals. Always, if you see a fractional exponent, you're going to have a radical. We didn't have a radical over here because there weren't any fractional exponents. The denominator tells you which root to take. The 100/9 goes underneath. And the numerator tells you which power to take. So I take the square root of 10, or excuse me, the square root of 100, which is 10, and the square root of 9, which is 3, and then I have to cube that. So I do 10 times 10 times 10, which is 1,000. And 3 times 3 times 3, which is 27. So the final answer, the steps go like this. The final answer is 1,000 over 27. Okay? All right, I'll see you either tomorrow in Flex or Wednesday in class. All right.